is Granucci, and my research is on machine learning for low-resource natural language processing, seeking to advance AI for linguistic inclusion. So what even is natural language processing, or NLP? NLP systems are defined as machine learning models that process and understand textual data, and they form the backbone of many foundational systems on the internet. Basically, wherever computer programs and text combine, you'll find a NLP system. They power everything from chatbots to translation services, sentiment analysis to search engines, and social media algorithms. A problem with NLP research, however, is that it has been mainly concentrated in a handful of high-resource languages. These are languages that have lots of data available, such as English, Chinese, and Spanish, and this is usually correlated with the amount of speakers a language has. This is a problem for low-resource languages and people seeking to develop machine learning models for these low-resource languages, because limited data and research makes it very difficult to develop the natural language processing machine learning models. A couple of constraints of my research project to improve performance of natural language processing models on low resource languages is number one, computational resources. So natural language processing models, they have to process text instead of raw numbers, so it takes a lot more data and time to train these machine learning models, and that is a constraint on my project. Second is data availability. Natural language processing models require a lot of text to be able to learn a language. However, for low-resource languages, they are by definition data scarce, so it is much more difficult to train machine learning models for these languages. And lastly, a lack of research. Since it's still relatively new to develop machine learning models for low-resource languages, there aren't a lot of studies that my research can build off of. All these constraints together have led me to formulate the question, how does cross-lingual transfer learning and pseudo-labeling improve performance of named entity recognition in low-resource languages? So this is a lot, but I'm going to break it down a bit. First, named entity recognition, NER. That is a natural language processing task that classifies each word in a sentence as belonging to one of some predetermined set of classes. For example, people, organizations, and locations, as you can see in this example. Each word is put into this class, and you can see Elon Musk is a person, Tesla is an organization, and this is an effective method to get structured data out of unstructured text, and it has a variety of applications, such as biomedical text analyzing, parsing legal text documents, and just dataset creation in general. The next term I want to define is cross-lingual transfer learning. This is one of the methods I will be using to improve performance of natural language processing models in low-resource languages. This essentially works by taking data from a high-resource language that's similar to the target language we are developing a model for, and training a dataset with that high-resource language. So an example of this might be if you're training a model to predict Icelandic, which is a Germanic language, you can add data from English, which is also a Germanic language, and this will actually improve the performance of the model, because the model first learns the general representations of the Germanic language family, then it can be fine-tuned specifically for the Icelandic task. Next, pseudo-labeling is the second method I'll be using to improve performance of NLP models for low-resource languages. Pseudo-labeling essentially works with two models, a teacher model and a student model. The teacher model is pre-trained on the limited low-resource data available, and it is used to generate pseudo-labels or predictions for unlabeled text, which is much easier to acquire than annotated NER text. So the teacher model generates predictions on unlabeled text, then these predictions and the text combine create their own dataset called a pseudo dataset, which a student model can then be trained off of. This just gives the student model more examples of what the data looks like, so it can better learn the representations for whatever task you set it to learn. So with these methods in mind, I was able to develop three primary objectives for my research. The first one was develop a baseline model. I am going to be testing different model architectures, state-of-the-art architectures, to see which ones perform the best for low-resource named entity recognition, and I will be selecting the best one as my baseline. Then I will be implementing my proposed approach, where I test pseudo-labeling and cross-lingual transfer learning to see how well this improves that low-resource NLP compared to the baseline. Finally, I'll analyze my results quantitatively and see what steps I can take to further my research. So first, data selection. This is the data all my models are going to be trained on. I chose the WikiAnd dataset. It's a well-known multilingual NER dataset. And from this dataset, I chose 6 low and high resource languages from similar language families. And just to get a diverse set of languages, testing my models on all 6 languages will help ensure that any performance gains is not for a specific language family, but it is generalizable across all multiple domains. First, I'll be training a baseline model. I'll be testing different model architectures proposed by Lei et al. In their study analyzing the different model architectures that work best for named entity recognition. I'll then be selecting the best one as my baseline. These are the results of the training the different model architectures for low-resource natural language processing, similar to the study by Lei et al., but BILSTM-CRF performed the best for named entity recognition. I then tested this model with data augmentation with cross-lingual transfer learning. So each of the low-resource languages got data added from an adjacent high-resource language, and as we can see, for most languages, performance improved in between 5 to 10% over the baseline. So this is promising because it shows that cross-lingual transfer learning does improve performance for low-resource natural language processing for NLP, and the largest improvement was by Shuvash and the Tatar languages, which improved 13% over the baseline, and this demonstrates that these techniques are effective at improving the performance of NLP models for low-resource languages. So future steps to build upon my current research, I plan on testing more advanced transfer learning techniques, so going behind simply data augmentation, I will be using 2 separate models, pre-training one on high-resource data, and then using the parameters from that model to train a new model only on the low-resource language data. I also plan on testing pseudo-labeling for low-resource NLP, and I also wish to expand upon the tasks I'm testing. Right now I'm only testing named entity recognition, but to make sure that my results are applicable to multiple domains, I could expand this to text classification, sentiment analysis, and other natural language processing tasks. These are the references that helped me throughout this research process, and thank you for taking the time to listen to my research.